Mr. Gubino here. We're going to go over the verbal FRQ medley from AP Live, the one that Mark and Verge did. This is on our Google Classroom. It is taken from the AP Classroom site, so all of these are permitted. And this is just a recap of what they did. I will be doing my own take on the version of this. If you want to watch the other video, please go right ahead. We're going to kind of get started with this first problem. There are 3 parts. I will cut on this, and then we will go for here in just a second. At the beginning of 2010, a landfill has contained 1,400 tons of solid waste. The increasing function W models the total amount of waste stored at the landfill. Planners estimate that W will satisfy the differential equation of dW dt equal to 1/25 W minus 300 for the next 20 years. W is measured in tons and T is measured in years from the start of 2010. So a couple pieces of information. So 2010 is our T equals 0, and our W of T, our start, is 1,400 tons. We have dW dt, and that is 1/25. And if you've been minus of W minus 300, if you have been paying attention to any of the problems, this probably has come up at least once, maybe twice. Okay, so these are just recaps of problems and just reworded statements. It says use the line tangent to the graph of W at t equals 0 to approximate the amount of solid waste that the landfill contains at the end of first 3 months, where time is equal to 1/4. All right, so what we're going to do is we need a point and a slope. And we need a point. We have a point. That's 0, 1,400. So there's my x, there's my y. I need a slope. Well, there's my slope. So what I'm going to plug in is I'm going to plug in what it would be at 1,400. So 1,400, 1/25 of 1,400 minus 300 is 1,100 divided by 25, basically. So how many quarters are in $11? And that would be 44. So that's our slope. Here's our equation. Y minus 1,400 is equal to 44 times t minus 0. You could leave it like that. But in this case, they're not asking you for the find the tangent line. They're asking to approximate this amount of solid waste. So we're looking for y if t is 1/4. Oh, all right. So y is equal to, I'm going to take that 1,400, 44 times 1/4. And if I distribute it, it's going to be 0 plus 1,400. So this is going to be 11 plus 1,400, which is going to give you 1,411 approximately. So we're going to do approximately 1,411 tons of waste. When t equals 1/4. Okay, so there's our first problem. I'm going to slide that up just a little bit so you can see that. So again, we don't need the tangent line. If they gave us and said yes, find the tangent line and then approximate, we'll need that part. But essentially, they're just asking for this part. Okay, so they want to know what it is going to be, and it's an increasing function, so it should be higher than 1,400. All right, part B says find the second derivative of W with respect to time in terms of W. Use the second derivative to determine whether your answer in part A is an underestimate or an overestimate of the amount of solid waste that the landfill contains at time t equals 1/4. So if we're looking for over or underestimates, we need to look at not only increasing or decreasing function, but we also need to look at concavity. So when we look at the first derivative, we are going to look at whether it's concave up or concave down. And if you notice, the increasing function w at the beginning tells us a lot. So we know that this is increasing, and because w is greater than 1400 always, that's going to be an increasing function. So we know that dw dt is greater than 0 for t greater than 0. Okay, so that's one part. So we know it's increasing. So we need to find the second derivative. So the second derivative of w in terms of t. So when we have this, we're going to take the derivative of this. This is a constant, so it's going to stay out there. We're going to take the derivative of w minus 300, which is 1, but we're going to multiply it by dw dt because we don't have a t in here. So we need to take the derivative of w in terms of t. Well, that's going to be 1/25th, and we know what that is because that's right up there. That's 1/25th of w minus 300, which is 1 over 625 w minus 300. Now, that is the second derivative. So when you see this, you might want to write the second derivative in terms of time is 1 over 625 of w minus 300, because they're asking for that. All right. The second thing that they want to know is use that to determine whether it's an over or an underestimate. The second derivative of w in terms of time is also greater than 0 for t greater than 0, which means it's increasing and concave up. So increasing, increasing, which means concave upward. And if it is concave upward, I'm going to show you do the graph and then do the tangent line. So if it's increasing and concave up, it probably has some form of graph that looks like that. That's just concave up and derivative. So if I look at a tangent line, anytime that you draw a tangent line to this, it is going to be where? Underneath. So you need this to state, you need this to state, therefore what does it ask? The answer in part A is an underestimate. Of amount of solid waste. Oh, of solid waste at t equals 1/4. Okay, so I'll leave that up there. Again, if your derivative is increasing, your function is increasing, and your second derivative concavity is increasing or positive, everything's positive, your tangent line here is going to be, there's your tangent is going to be underneath it, so it's an underestimate. You really need to state whether it's an over or an underestimate. That's the biggest thing that you need to show. Okay, now we're going to head on to part C. All right, find the particular solution. W is equal to Wt to the differential equation with the initial condition of W of 0 is equal to 1400. So basically now what we're going to do is we're going to find the particular solution. So we're going to find the integral. dw dt is 1/25th of W minus 300. This is the process you need to show. So you want to gather W's on one side and dt's on the other side and t's. So dw over W minus 300, do not distribute the 1/25th, is 1/25th times dt. Once we get that, you need to show that part, and then you need to show this. You need to put the integral signs on there. And what that's going to do is it's going to say, okay, now I know that it's the natural log of W minus 300 equal to 1/25th t plus c. All right, so now when we get that equation, the first thing that we're going to do once we get that is find c at the point 0, 1400. And what that does is it'll give us the c value. Don't find it last, find it first before you go into the extra steps. Because I did this problem and I put in c, once I get that, I said c is 1100. That's wrong because you got a plus 300 over here, so I think you can see where it's going to go. So if I plug in 1400 for W, whoops, didn't leave enough room, equal to 1/25th times 0 plus c, you notice c is the natural log of 1100. Okay, perfect. There's our c value. C is the natural log of 1100. So when I write that equation, I'm going to go over to the right-hand side. I'm going to have the natural log. So I'm going to go up there, and I'm going to use this equation and that one of W minus 300 equal to 1/25th t plus the natural log of 1100. So you're going to kind of see where the c comes into play in just a moment. So when I take this, what I have to do is take the e, take the natural log of both sides, and when I take the the natural exponent of both sides, these powers, this becomes W minus 300, and essentially we can get rid of the absolute value because that's always going to be positive no matter what. What this happens here is that with the plus, we're going to have e to the 1/25th t plus natural log of 1100. Well, this is going to be e times, so e times natural log is going to be 1100 out front, e to the 1/25th t. And then if I subtract 0, or 300, add 300, is 1100 e to the 1/25th t plus 300. So if you notice, when I plug in t equals 0 into this equation, I get e to the first, which is 0, or 1. Okay, e to the 0th is 1 times 1100 plus 300 is 1400. So I have to have that value in there. So as you're going through these, as you're going through these, pause every single time, try to do it, and then maybe walk through the process. Each time that you see them, make sure that you're doing them correctly. Pause this video, go back through, try it again. Okay, we're going to go on to the next problem here in just a second. All right, so here is question 2. We are looking at two particles moving along the x-axis for 0 to 6 seconds. The particle of P is given at the time of P of t is equal to 2 cosine pi over 4 t. And the position of particle r at the time t is given by r of t is equal to t cubed minus 6t squared plus 9t plus 3. A, for all times between 0 and 6, find the t where the particle of r is moving to the right. Well, what we need to look at is the velocity is greater than 0. It's going to move right. You're picking up your foot, or you're putting on the gas pedal. If your velocity is less than 0, you're moving to the left. So this is one of those that we got with first derivatives test. So we're going to take the r of t, not the first derivatives test, I'm sorry, with finding the derivative, setting it equal to 0, and finding extreme points. So we got 3t squared minus 12t plus 9. We're going to set that equal to 0. I'm going to factor out the t, or the 3, minus 4t plus 3. And then I need factors of 3, whose sum is negative 4, which is minus 3 and minus 1, which gives me the values of t equals 1 and t equals 3. Those are our critical points. We're starting at 0. We're going to, let's do 1, 2, 3, 4, 5, and 6. So our critical points were at 1 and 3. So we need to do a test between. Again, I put it back into here. I'm going to test 1/2. I'm going to test 2, and I'm going to test 4. So a half positive times a negative is a, what is it? A positive. If I take 2, positive times a negative is a negative. And if I take 4, I get positive times a positive, which is a positive. So R moves right on the interval from 0 to 1, and on the interval from 3 to 6. Okay. If you wanted to write this, you got t to 1 and 3 to 6. You could write it that way as well. I like the interval notation myself. Okay, so that's part A. Part B. All right, B is asking for which times t are the two particles traveling in opposite directions. So if one's moving right, the other one's moving left, left and right, etc. So we already have where it's moving right for R. We know where it's moving left, so it's moving left. We didn't write this down. We didn't need to, but it's left between 1 and 3. Then what we're going to do is look for the overlap between those. So we need P, and we need to find P prime. So there's P. We need to find P prime of T. So that's 2. Derivative of cosine is negative sine, so I'm going to put that out front, of pi over 4t. Oh, we got a little chain rule, so we have to multiply that by pi over 4. So what we're going to get is, if we clean this up, we're going to get the derivative of t equal to negative 2 times pi over 4 is negative pi over 2 sine of pi over 4t. We're going to set that equal to 0. All right, and we get the sine of pi over 4t is equal to 0. So where is, so I'm going to go up here, the sine of pi over 4t equal to 0. Well, sine is 0. Sine is equal to 0 at 0, at pi, and at 2 pi. And what we're going to do is we're going to take the pi over 4t, and we're going to set it equal to each of these. And then what's going to happen is we're going to solve for t. So t is obviously 0, t is 4, and t is 8. The only ones that are in the interval are those two. Okay, so let's do a table, and then we're going to take this table and overlap it, and then we're going to see which one is overlapped, where it moves in opposite directions, where are the signs going to be negative. So 0, 1, 2, 3, 4, 5, and 6. So 0 is one of the times, and 4 is one of the times. So if I pick a value of 2, and if I pick a value of 2, the sine of pi over 2 is 1 times negative. Here's my derivative that I'm going to plug into. So if I plug in 2, I get pi over 4 times 2, which is pi over 2. And the sine of pi over 2 is 1. 1 times the negative is a negative. If I took, let's say, 5 pi over 4. 5 pi over 4 is in the third quadrant. That is negative, where sine is negative. All students take calculus. Negative times a negative is a positive. All right, now what I'm going to do is I'm going to overlap what we got for this. So R So in between each one, so this is what I'm going to do, is I'm going to put a negative, 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 positive, positive. That's for P. And then I'm going to put a positive, a negative, negative, a positive, and a positive. So now what we're looking at is where are the two signs different between these two and between those two. So we would say R and P are moving in opposite directions during the times of 0 to 1 and 3 to 4. Okay, so between these two times, those are the times when they are moving in opposite directions. Restate the question. If you look at the question, what is it really asking for? Okay, this is the good calculus that they're looking for. Part C. Part C is asking, find the acceleration of particle P at time t equals 3. There's one thing we got to find. Is the particle speeding up, slowing down, or doing neither at time equals 3? Explain the reasoning. So if we're looking for speeding up, slowing down, or doing neither, what we are basically looking at is how are velocity and acceleration moving. If they are the opposite signs, then it's slowing down. If they are the same sign, it is speeding up. If one's 0, then it's neither. Okay? So what is happening in this case? So we need to take what we had for P prime of t, so this is C. P prime of t is negative 2 sine of pi over, oh, nope, that's not it, sorry. P prime of t is this one, negative pi over 2 sine of pi over 4t. All right, so this is P prime of t. So we need the second derivative of t. Oh, sorry. So, well, you didn't even see that mistake that I made. So, part C starts here. It doesn't start here, no matter what you think you see. All right, so we need to see the acceleration. So we need the derivative of this. So this is a constant. We have the derivative of sine, which is cosine. We get back to cosine. We get pi over 4 times t, and then we got to take the derivative of the inside, which is the chain rule of pi over 4. So p double prime of t is negative pi squared. Yes, pi times pi is pi squared over 8 cosine of pi over 4t. They want to know p double prime of 3. Okay? So we got negative pi squared over 8 times the cosine of 3 pi over 4. And let's go this way. Negative pi squared over 8, and the cosine of 3 pi over 4 is, yep, the negative square root of 2 over 2. Cosine is negative. That's a second quadrant angle. Cosine is negative in the second quadrant. All students take calculus. Cosine is negative. So this is going to yield a positive value, which is greater than 0. So the acceleration, I guess we could say p double prime of t is greater than 0, where v, the velocity, is, what is the velocity at t equals 3 of p? Well, that's negative from up there. So if the velocity is negative and acceleration is positive, so therefore both are, I guess we don't say both. they have the opposite signs. P is slowing down at t equals 3. Whew. Try and get those words cleaned up a little bit, Mr. Guvino. All right, so the velocity is negative and the acceleration is positive. Positive at t equals 3, meaning they have opposite signs, which means it is slowing down. So they need to see the word slowing down. Okay, you can just put slowing down, but they may only give you a point. They might be worth 3 points. You need to put that extra point down. All right. Well, part D, there's a third particle, Q. Oh, great. That moves along the y-axis, perpendicular to the path of particles P and Q. The position of particle Q at time t is given by Q of t. At time t equals 2, Q of 2 equals 4, and Q prime of 2 equals 6. Describe how the distance between particles Q and R are changing with respect to time at t equals 2. Sounds like a related rates problem because you are taking two rates. You get a rate for Q and you get a rate for R. So what we're going to do is we're going to find the related rates with those two values. All right, so we have a couple things. We have Q. Q is moving along the y-axis, going that way. R is moving along the horizontal axis. How do I know that? It's in the first part of that equation. Two particles move along the x-axis. All right, so I have particle R given by this. At time equals 2, we know that Q of 2 is equal to 4, and the derivative of that is 6. So dq dt is 6. Big Q, little q. I'm going to use little q, I guess. All right. So R of 2, if I go up to the equation right here and put R of 2 in, I get 5. And I know the derivative at 2. I can find the derivative at 2. I can find the derivative at 2. So that is negative 3. So 3 times negative 1 times 1 is negative 3. Okay? So we're going to use those two values to find what we're doing. And I do believe what's happening is you have the distance between those. All right, so what we're looking at is we're looking at Q moving up, R moving, and actuality moving left. So what's happening to that and how it's speeding up or slowing down? Well, the derivative of the distance is what we are looking for. And in this case, we are going to find, well, I think it's going to be moving. So R is moving that way, Q is moving that way. We're going to use the distance formula because we want to look at the distance between R and Q. So we want to know the distance when R is at 5 and Q is at 4. The y values, okay? So the distance is going to be the square root of 5 squared plus 4 squared, which is the square root of 41. That's going to come into play here in just a second. But what we want to concentrate on is r squared plus q squared. That's our distance, and we want to know from here, we want to know, describe how the distance between q and r is changing with respect to time. So we need to find dd of dt. It's a lot of, okay? So the distance, the derivative of the distance in terms of time. So I take the derivative. This is a related rates problem. We have 2r dr dt because we're taking it in terms of t. And then we have 2q and dq dt. We're looking for dd dt, and if I divide by 2d down here, these 2's cancel. So basically, if I have d, which is right there, the square root of 41, I have r is 5, with a rate of -3, and I have q, which is 4, and a rate of 6. This is going to be 9 over the square root of 41. Does it ask for units of no, because there are no units that go along with it other than time, but time is not specified. So it is moving at 9 over the square root of 41. Okay, so that answers question 2. We're moving on after this. I'm at 30 minutes, so I'm going to try and hurry up for the other one. All right, number 3. Function defined f of x is equal to the square root of 25 minus x squared for -5 to 5. So the first thing I want to look at is we're going to use this geometrically as well. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's -5, that's 5. It has an intercept at 5. And pretty much this is a semicircle. Pretty good. With a radius of 5. Okay, so this is going to come into play when I get into the other values. So part A, what is f prime of x? Well, f prime of x is, well, let me write down what f of x is. F of x is the square root of 25 minus x squared, which is 25 minus x squared to the 1/2 power. Power rule, we bring the 1/2 out front. We keep the inside. 25 minus x squared. We drop this by 1. And then we got to multiply by this derivative because of the chain rule. So that's minus 2x. That is an acceptable answer, but let's clean it up a little bit. This 2 would be -x over the square root of 25 minus x squared. Okay, so f prime of x is equal to that. We don't need that little part in there. Okay. All right, next find B. Find the equation of the line that is tangent to the graph of f at x equals -3. Well, f of -3, I need that point, is going to be 25 minus -3 squared, which is going to be 4. So part B, I need this and I need this because I need to find what f prime of -3 is. And that's going to be +3 over, oh, well that's going to be 4 still, right? 25 minus 9 square root is 16. So I have the equation now. Y minus, there's my y value, is equal to 3/4 times x plus 3. There's the equation of the tangent line. That's all you need to write. Now if they said approximate the value, blah, 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 at 3.1, then you're going to take that value. We're good on those. Okay. Part C. Pause it. Ask any questions if you need to. Part C. All right, so we have a function that is defined by f of x from -5 to -3 and from x plus 7 from -3 to 5. So basically what that looks like is I know what this looks like from -5 to 3. It's going to be this. Then what's going to happen is you're going to get this linear function in, and that linear function, what's happening is if I get this part, which is square root of 25 plus minus x squared, at x plus 7, it might look like this now. Okay? So what's going to happen is you have this part, and we need to see if that part right there, we're checking to see if it is continuous and differentiable at -3. So it's asking you, Use the definition of continuity to explain your answer. Is G continuous at x equals negative 3? Well, the definition. So by definition of continuity, I guess we could say it that way. 1, we have to see if, in this case, what do we got? G of x exists. 2, we need to see the limit as x approaches a of g of x exists. And 3, just because we have those two, we kind of, you go along and you go, oh, well, if the first two are correct, the third one has to be correct. Sometimes, most of the time. But we have to state it. So g of x is equal to the limit as x approaches a of g of x. Okay, so we need those two to be equal. So let's check number 1. Let's check to see if g of x exists. So 1, if I have g of x and I want g of negative 3, because I'm checking at x equals negative 3. So what I need to do is I need to determine which one of those functions am I going to check for negative 3. Well, negative 3 occurs at f. Well, that is going to be the square root of 25 minus negative 3 squared, which is 4. Got it. Does it exist? Yes. Why don't I have to check the bottom one, Mr. Gubino? Because 3 is not included in that function. We're checking to see if it's part of that function, because sometimes what happens is you might get a graph that looks like this and then it looks like that. And it looks like this and then it looks like that, and we have to see where the hole is. If we're going at negative 3 and it's part of that, does it exist there? Okay. Just checking to see if my cat can get out of the... Yes, he can. Or she, sorry. All right, so that one is good. Part 2. Let's go to green. All right, part 2. We have to check the limit, but in this case, we have to check the limit as x approaches negative 3 from the left. Well, as x approaches negative 3 from the left. So we're going to check square root of 25 minus negative 3 squared, which is 4. Yep. Then we need to check the limit as x approaches negative 3 from the right of g of x. And when it approaches from the right, we're going to use the x plus 7. So that's going to be negative 3 plus 7, which is 4. So therefore, the limit as x approaches negative 3 of g of x exists. Done. Now, do they equal each other? 3. So, by... Right, sorry, I'm going to switch pens. By definition of continuity, g of negative 3 is equal to the limit as x approaches negative 3 of g of x. Therefore, g is continuous at t equals negative 3. Okay. I gotta get this raised up so you can see, and I'm writing probably within the screen. I'm sorry. That's just the way it's going today. All right, so part D. And I'm glad they put in the x there. They want to know the definite integral from 0 to 5. Excuse me, I'm sorry. They want to check to see this, and the reason why this will work is because if you look at this function, this is the more difficult, is that a derivative or portion of a derivative like that? And the answer is yeah. So what we're going to do is we're going to do u sub 25 minus x squared. So du is negative 2x dx. All right, so I can get the x and the dx out of the way. So I get negative 1/2 du equal to x dx. I do it that way. Some teachers do it a different way. They'll do negative 1/2 over dx is equal to x. You're still going to get the same answer. So we get negative 1/2 times the square root of u du from 0 to 5. And the most important thing in this case is these are the x values. So to be consistent, I don't want to replace this with 25 minus x squared. I can. No question, I can. I can do it that way. I'm just wanting to show you this because sometimes they will put that in. So if x equals 0, then u is 25. And if x equals 5, which is the top, u equals 0. So this would be negative 1/2 from, guess what, that switches 25 to 0 of the square root of u du. All right, so what do we got? We got negative 1/2 times u to the 3/2 and then times by 2/3. So I have that little space in there. And we're going to go from 0 to 25. This is what? Negative 1/3. Oh, sheesh. Okay, so negative 1/3 we're going to bring out front. And then we're going to go 0 to the 3/2 minus 25 to the 3/2. So that's negative 1/3. And we got 0. And then this is the square root of 25, which is 5 cubed is 125. So that is 125 over 3. Leave it. If this was a calculator question, could you use the calculator? Yeah, by all means, use the calculator. So we're going to look at the definite integral from 0 to 5 of x times the square root of 25 minus x squared dx, and it's going to come up with a 41.67766666787 whatever. That's 125 over 3. Okay, so those two values are going to be the same. So we can leave it like that. All right, NE. We did this one before. Oh, no we didn't. Okay, so the value of that from negative 5 to 5 of 6f of x plus 3 dx. I'm going to break it up, negative 5 to 5. All right, 45-minute 6f of x dx plus negative 5 to 5 of 3 dx. So this is 6 times the integral from negative 5 to 5 of f of x dx plus negative 5 to 5 of 3 dx. All right, so f of x dx, this, we have to use the knowledge of what is the area underneath that curve. So we have to go back to, sorry, I'm just moving things around. We have to go back to this knowledge of what is the area underneath this curve, because this is f of x. Okay, that's what that is up there. So what is the area under this curve? Well, it's a radius of 5, and it's a semicircle. So that's 1/2 pi r squared. So it's 1/2 of pi times 5 squared. So 25 halves pi, if you want to look at it that way, and then times by 6. So 6 times 25 pi over 2 plus, this is a rectangle. And how do I know it's a rectangle? Well, y equals 3 going from negative 5 to 5. That's just a rectangle of height 3 and 10, which is 30. So this is what, 75 pi plus 30. There's your answer. Okay. Any questions? Okay. So, let's go back to me. Hi. And we're going to go through. If you need any questions, I'm going to post these answers. You will see each sheet of paper with attached to a whole sheet of notes of worked out answers, or not worked out answers. The worked out answers will be the 3 pages after. So I hope you can go back through this if you need to watch any of the videos. Okay? Have a good day.